we have it tied to those two planes there, and we have a horizontal relation. So what I'm going to do, I'm going to look at this thing normal again, and I'm going to drag this line down to where I think it should be on the body here. Now once you expand these blueprints and you start to really look at them, you'll notice that they're very pixelated. The resolution on at least this set of blueprints isn't very good. Not really an issue in this case because we're not trying to reproduce this. We really don't care that it's going to be an exact model. It's just going to be a really general reference. You're going to look at this thing and you're going to say, oh, well, you know, that's a Predator drone, but you're not going to be selling these planes to the Army or anything like that. So what I like to do is define these. I'm going to add relations, dimensions, and everything to fully define my sketches wherever I can. Now this number doesn't mean anything. It's off my origin, it's where I planted everything, but it's really just a nice round number that I'm giving to this line to put it, you know, in that place. And you'll notice once you scale these things up, the numbers are going to work out pretty nicely. The next thing I'm going to do is sketch on this top mid plane. And again, I'm going to look at it normal. I'm going to draw a line. I'm going to let the auto constraint add a vertical constraint to that. And same thing again, we want to tie this to this plane and the tail plane. Now sometimes you might have trouble selecting some of these depending on what's in your way. So you might need to rotate things around or grab the planes that you want from the feature manager. Alright, and next just drag this over to your model, roughly where you think it'll be, and let's add a dimension here. Alright, that looks pretty close to 400, so I'm just going to throw 400 in there. And again, you know, not being real precise here, it's just a very general representation. Because I don't really need to see these planes, I'm going to go ahead and just hide them all. I know they're there. I know just by looking at the name, you know, this is the tail plane, that's the plane I want to sketch certain things on, this is the mid plane. And that really goes back to your naming convention. You don't need to say, oh, what was plane 1, you click on it, oh, there it is, make it visible, sketch on it. You really just need to streamline this as much as possible, and also, you know, hiding all this will speed up your system if your computer, you know, maybe has trouble viewing all three of these pictures at the same time. Alright, so from here we have these two lines, and what we're going to run into is a slight problem. Now if we look at the front blueprint, that is the nose of the plane, and the fuselage back here is actually smaller than that. So we don't really have a good reference for the shape of the body back here. We have a top view and a side view, but we don't have a back view. There wasn't one available for this. So what I'm going to do is just sort of guess. You can look at pictures and make your own judgment calls, but what I'm going to do is take a spline, go to these 2 points, and what I'm going to do, I use the escape key. You can right click and say end spline. Either way, it doesn't really matter. But what I try to do is use as few spline points as possible. And the reason being, if you click on a spline, you have this option over here in the properties to show curvature. You get some options over here. You can change the length of the whiskers or whatever you want to call them over there, and you can change the density. You can kick it way up or you can kick it way down. And so let's pull these in a little bit, and we'll kick the density way down. So really, once you start adding multiple points in here, having a nice transition on this curve is going to get harder and harder for you to do, especially when you start messing with these handles in every instance. But what we want to do in this case, we know we're only mirroring, or we're only modeling half of the vehicle, and we're going to mirror it across the center line. In order to avoid having a seam down the middle, I'm going to go ahead and click on that handle and apply a horizontal relation. So I know when I mirror the body we're going to create over, over the right plane in this case, that at that instance the curvature is going to be the same. Now there's a little trick to that as well. Now let me actually undo that horizontal relation and show you something else. Don't be afraid to create construction geometry whenever you need it. So I'm going to make a horizontal line there. I'm going to make a vertical line here, and I'm going to make an extra little line coming out here. And actually, let me turn off the curvature comb so you guys can see this thing. Alright, so what I'm going to do, I know from looking at pictures that the side of this isn't vertical. It's got a little bit of an angle to it, and the underneath side of the body actually curves back. So I'm going to go ahead and I'm just going to apply an 8-degree angle to this, and I'm going to go ahead and give this a value, 1,000. It looks pretty good. And up top, I'm actually going to go ahead and select this line in the spline, and I'm going to apply an equal curvature relation to it. Now this is an interesting situation because this is a straight line. There's absolutely no curvature. So when you're dealing with a straight line, tangent and equal curvature are going to give you essentially the same thing. Where this is really going to come into play is if you start dealing with splines or surfaces, their intersection, you're going to want to be real careful about whether you do tangent, whether you do curvature, or if you just do intersection, if you want a hard seam there. If you start to do some research and you hear people talk about Class A surfacing, there's a little well, there's some relations that you need to be aware of. Class A surfacing basically talks about the curvature of the surfaces, how the reflections hit the surfaces, how surfaces match up with the surrounding geometry, and there's going to be a scale. When you talk about G0 continuity, it's actually just intersection. You're going to say that one surface intersects another surface. When you start to talk about G1, then you start to talk about a tangent relationship. So basically where a surface hits another surface, at that point they have the exact same curvature. In this case, since we actually added this equal curvature relationship, we're talking about G2 continuity, which deals with the radius of curvature. And it's going to be really hard to show you this in this instance, but hopefully later on in the model we can talk about it some more. But basically, since this is a straight line and we don't have curvature, it's going to be really hard for you to see. And then there's also a G3, which is the acceleration. And now that actually refers to the rate of change of the curvature in the intersection area. So if you can kind of picture this curve, it's changing a lot more at the top here than it is down here at the bottom. So the rate of change, or the acceleration, is going to be higher up here at the top, and that's what they're talking about when they talk about this, the G3 continuity. So hopefully that's just a little basic introduction. Like I said, in this case, since we're talking about straight lines, tangent and curvature, you're really not going to see a big difference between the two. I'm going to go ahead and add a dimension to this line, and I want to show you something real quick. I'm not sure if the screen capture is picking it up, but there's a little mouse icon that's following me around, and it has the right mouse button highlighted. This dimension, as soon as you start to drag away from this line, snaps to a vertical dimension. When you see that mouse button, if you click the right mouse button, it will actually lock that dimension in, so you're actually giving the line a length and you're not worrying about the vertical distance between the endpoints. I'm going to go ahead and just give this a 500 millimeter length, and that should be apparent here shortly. Alright, I'm going to exit out of that sketch, and if we look at this, we now have that one spline on the back edge, and Actually, hold on one second. Let me go back in here and